Hi, here I'm going to show you an example of how to divide two complex numbers. We have 3 plus 5i divided by 2 minus 3i. So to do this, we're going to recognize that this is pretty much exactly the same as rationalizing the denominator. So we need to multiply both the top and bottom by something so that we can end up getting rid of the i's, which is the square root of -1, in the bottom. So we're going to multiply, as I said, both the top and bottom by the same amount so that we keep the fraction equivalent. And what we want to do is use the conjugate of whatever we have on the bottom. Since here you notice we have 2 minus 3i, we're going to go ahead and multiply this top and bottom by its conjugate, 2 plus 3i. Again, the only difference being the plus and the minus. If you have one subtracted, you want the other one to be addition. So, since we want this to be an equivalent fraction, we're going to go ahead and multiply both the top and bottom by this amount. Since these are complex numbers, we're going to kind of treat the I like a variable in the way that we multiply them, meaning that we need to FOIL this out. So for our top, we're going to actually go ahead and FOIL this, multiply the 3 through, then multiply the 5i through, and for the top we're going to end up with 6 plus 9i plus 10i plus 15i squared. As I said, the I, we treat it in calculations very much the same way we would treat a variable like x, even though it actually represents the amount, the imaginary number, the square root of -1. This is going to be all over. Well, we're going to go ahead and FOIL out the denominator here. Multiply the 2 through, multiply the 3 through. And we're going to end up with 4 plus 6i minus 6i minus 9i squared. So first thing we want to look at is if we have any common or like terms in both the top and the bottom. We have here for the top 9i and 10i. Since those both have an I in it, they are like terms, we can go ahead and actually simplify those. So let me move this up so we have a little bit more room here. And we're going to end up with the amount 6 plus 19i plus 15i squared. This will be over. Well, in the denominator, if you look, because we chose to multiply these by conjugates, we end up with these like terms in the middle, plus 6i minus 6i, and they actually will cancel out. So we end up with 4 minus 9i squared. So again, let me move up a little bit so we can get more room. For complex numbers, whatever operations that you're dealing with, you want to make sure that you never ever leave any I squareds in there. So looking at this, you notice that we have I squared right here, and we have another I squared right there. We want to simplify this by recognizing the fact that I squared, that's I squared, is equal to -1. So where the I squared was, we want to go ahead and instead substitute in a -1. So we end up with 6 plus 19i plus 15 times, instead of I squared, -1. And this will be over 4 minus 9 times -1. Now that we have more like terms, we can go ahead and simplify those. You notice we have the constant terms in both the top and the bottom, the real part of each of these complex numbers. And we are going to have 6 plus, here 15 times -1 is going to give me -15 when we simplify. So 6 minus 15 is -9 plus 19i in the bottom, we're going to have negative 9 times negative 1, which is going to give me plus 9. 4 plus 9 is 13. We're very close to being finished, but you notice by doing these steps, multiplying by the conjugate, we now in the denominator have just plain old 13. No i's whatsoever, no square roots. So we have finished the basic steps of dividing. All we need to do is simplify this number and rewrite it in standard form. For complex numbers, remember standard form is a, the real part, plus b, I, the imaginary part. And we want it to be in that exact format. So I'm going to, again, move over one last time, have a little bit of space here. And we simplify this by just breaking up the fraction into two parts and realizing that we have negative 9 over 13 plus 19 over 13i. And that'll be our final answer in standard form. That's how we divide complex numbers. I hope this helps.